Hey y'all, got my first little project done. Built a rack and pinion. Yeah, this is a little under a 1-inch pinion gear. The rest of the video is a little bit of recording where I cut this gear. I done just a little bit of it because it takes a long time to cut a gear with a milling bit if you don't have the actual gear cutting tools. I don't have them yet. I was just playing, but this is going to the homemade milling machine. It will be the spindle feed. As you can see, it's good enough. It ain't precise, but it'll work for what I'm going to do. So enjoy the video. Hey y'all, Brett, Hillbilly Custom. I know, new name. Gotta get used to it. I really won't say the other name. But I've had more than one person ask me what I bought this machine for, what I was going to do with it, and they like to see what I'm going to make. I know I've had several comments. And I've showed my work in a few places, so I thought I'd make a little short video of what I got going on. Like I said in some of the other videos, I'm building a gear. I'm actually building two gears, called a rack and pinion. My homemade machine needs a spindle feed handle, and it needs a way to push the spindle up and down. Most of them have something similar to a rack and pinion. That's what I'm gonna call it. It's a basic one. But my first project, yes, is a gear, and it's been a pretty good size project. I don't really have the tools to make gear teeth like I should, so I'm making them, you can say, the hillbilly way. I'm using hillbilly math. And if somebody's interested in knowing my hillbilly math and seeing how I figured this out, I'd be willing to make a video about hillbilly math, but I don't know how exciting it would be. That's really nice that if somebody wants to see it, I'll make one. Well, let me show you the gears. First off, this is the rack gear. Them are 1/8 inch teeth. I machined it out. I filed it and cleaned it up. That's about 5 inches long of teeth, really close. Now, I haven't measured. I just cut teeth. I felt like it was enough. I know roughly what I really need. It doesn't have more than a 4-inch feed, but if I had 5 inches of teeth, that would give somewhere for the pinion to roll. I didn't make a video about this because this is just basic math. It's simple. You cut an 1/8 inch gap, you leave an 1/8 inch ridge. You cut an 1/8 inch valley, leave an 1/8 inch ridge, and so on. And then you file it. I had to file it to make the teeth out of it because their teeth's not technically square. They're rounded on the ends, and they come down in the bottom's usually a little rounded the opposite way. One's concave, one's convex. But you can see it's been filed down and slicked up some. I made this first. I was excited over this. But this is my newest project. This is the pinion. I have been working the hillbilly math. There it is. And I have cut several teeth. And so far the spacing is working out really well. Yes, I tested against this. If it will roll across this, my spacing is working. Even though them teeth are still square. You can see, I can get in there. This is a pretty good project for me. It's been a long time since I cut something this technical, this precise. It's a lot of math in it. I'm used to the fab shop kind of just cut it, make it fit, working on fractional sizes, and we go with it. I haven't done a real technical measurement job in a long time. Every once in a while I throw one in, but not this size of a job, not one that takes this long. I've made some pretty unique stuff over the years, and there's no videos to prove it, so all I can do is claim it. But I'm going to start videoing more of what I'm doing. I'll probably turn the video camera over to the stand and run a couple lines here and show you what it looks like, but It's basically what I'm doing with the machine. I'm starting out building things that I need. And if somebody needs something in the community, we'll work something out. Well, let me turn it over to the stand. I'll give you a few minutes of that. Let me crank the machine. We'll see how the sound is. Maybe it won't be too loud on the camera. We'll start with a light cut, make sure everything's good. That's not the wrong target. That'll lock everything down. This is basically how I cut teeth. I get all my measurements right, I get the bit lined up in the right spot. I slowly feed it back and forth until I get the groove that I want. That's pretty good. Kind of do a little more line there. Something don't quite look right, but it's close. I missed my mark now, just a fuzz. I think it's pretty close. I think I'll run with that. If you see the basic idea, I'm going to go ahead and cut it. I'll turn the camera back on after I get this one cut, because it's several passes really slow because we're trying to make sure it's right. I'll turn it back on in a second. Well, here you go. I've cut that one tooth. I was going to show you the lines. You see the grid I got drawn on there? That's part of that Hillbilly math. That grid helps me pick out where the teeth go. There's a lot of math figuring in that. But you see get down here, the teeth, they fit. They're square, so it don't roll good till I file them, but you got to file that sharp edge off of them. But like I said, you get that sharp edge off, they just roll right in there. That's how I'm making the gear. I use the dials and count the numbers, and I know where to make the next cut at it, but the grid also helps me get alignment too, because sometimes you get messed up on the numbers. The numbers are tiny. You know, it's 100. Turning the wheel only moves at 100 thousandths, and you've got to keep up with exactly where you're at. Anything distracts me, I get lost sometimes and I have to have a visual to make sure I'm on target, which I've got a lot of stuff zeroed here, so I know, but that's the fun. Won't be long. I'll drill this out to a 1/2 inch. I've got a set of broaches. I'll broach a keyway in it. We'll make a handle, and that homemade milling machine will have a feed similar to this one. Thanks for joining me. Y'all have a good week.